Okay, we're going to start a unit on limits. We're going to start with using tables and graphs. So the first thing we want to think about is to look up the word of limit. So if you're limiting something, then what are you doing? You're not taking the whole thing or something like that. So that's a little bit different than what we're talking about. So we're going to kind of have a phrase. Limit is the y. Okay, so let's keep that in mind. Excuse me. So for limit notation, just like we had f of x for function notation, now we're going to have limit notation. So we're going to have the limit as x goes to c of f of x equals L. L for limit, right? So in words, the limit as x approaches a number c of the function f of x is equal to L. And L is our limit. Okay, give everybody a chance to get that written down first. Okay, we're going to look at some different types of graphs that we might have. We might have one that comes down like this. And we have this point right here. The c value of f of x is going to have a certain value, and we call that L. So this is f is defined at c such that f of c equals L. So this is the point c that's going into the function, and then that's going to be our output from the function, the limit. Another possibility we might have where we have this curve again, but there's a point missing. But instead of it being totally missing, it's just up here. So again, that's still c. But now L is not there. There's another one up here. So this would be f of c. So this one is f is defined at c. That would be this one, right? F is defined at c. But f of c does not equal the limit. All right, the third one is this one. Same idea, we have an open circle, but this time we don't have a c. So this is going to be my c's place, and this is going to be my L. So this one, what do you think? F is not defined at c. Okay, so give everybody a chance to get those written down first. And this is not fis, this is f is. Same thing, f is. All right, we're going to take your calculators and we're going to plot some points or substitute some points in on the next part. We said tables and charts. Okay, so we're going to graph tables and graphs. So we're going to graph the line y equals 2x minus 1. Okay, so what form of the line is this? This is slope-intercept, so y equals mx plus b. So you know how to graph this. We go to y-intercept of -1, and we put a dot. And then from that dot, you're going to do your slope, which would be 2 over 1. So rise over run. So we're going to rise 2 and run 1. Rise 2 and run 1. Do that a couple of times back and forth. So we have an easier way of drawing our lines. So this is going to be our line. Okay, now we're going to plug the numbers into this 2x minus 1 and see what we get. So we're going to first put the first one in, 1.9. So everybody got your calculators? You're going to plug in 1.9 and see what you get. Now see what this is doing? This is trying to show whether it really does approach 2 and at what number it does approach 2. So 1.9 should be 2.8. And 1.99 is 2.98. You're substituting these in with your calculator, so you can do that on your own. And over here we've got 3.002 and 3.02 and 3.2. So if I go from left and from right, straight in, what do these things approach? What would be that number in between them? So this number in between them, from here to there and from here to there, would be 3. So we're going to write that from this side. We're going to say the limit as x goes to 2 from the negative side of 2x minus 1 equals, so going this way, then it equals 3, right? And the same thing on this side, we're going to say the limit as x goes to 2 from the positive side of 2x minus 1. So this would be from the positive side, is also going to approach 3. So since both of them are 3, then therefore, right, the limit as x goes to 2 of 2x minus 1 equals 3. Now, when we look at this, we think of ourselves as it approaches 2. So as it approaches 2, where is it? Okay? So if I go along here, and I go up from here, and I go down from here, as it approaches x equals 2, so this would be x equals 2, right? This is 2 down here. Then what is my y value? My y value is the 3. And there we go with the 3. So it shows up the same thing on our graph. So if you want to, you can put like little arrows pointing to that, and then another one coming from here, so we know that they're both approaching that same point. Okay, we'll look at another example. Okay, we're going to go down to example number 3, but we're going to go ahead and fill in the notes part first. Okay, cited limit notation was what we were talking about a few minutes ago. As x approaches from the left, so the left would be from the negative side, we're going to write the limit as x approaches c from the negative side of f of x. So this does not mean multiply by a negative exponent, it just means from the negative side. And over on this one, as x approaches from the right, so this would be the limit as x goes to c from the positive side of f of x. So that was that idea, right side, left side. So we come together in the middle. The exponent sign on the number c tells us which direction you're coming from, and it's read the limit as x approaches 5, in this case they have a 5, from the left to the function is equal to, and then it leaves it blank. Okay, so now we're going to do example 3. So example 3, we're looking at this piecewise function. Okay, so when it's less than 0, then y is going to equal x. When it's greater than 0, then we're going to equal 1. Okay, so when x is less than 0, y equals x, and so forth. So we're going to graph the two things. So what two things are we going to graph? This is the same thing as saying y equals. So y equals x, and y equals 1. Now, the ones that go to the right of 0, but not including 0, right? See how both of them have an open circle? Less than or greater than is going to be open circle. It's only if you have an equal to that has a closed circle. So in this case right here, y equals 1. We know that we're going to have an open circle on 1 and an arrow to the right, because it says that y equals 1 when it is greater than 0. Y equals x. Y equals x is like x 1, negative 1, negative 1, negative 2, negative 2, and so forth, because now the x's have to be less than 0. So we have an open circle here, and then we go down here, here, and make our line. Okay, so far? So we're going to plug some numbers in again. So negative 0.01 gives us negative 0.1, and negative 0.01 gives us negative 0.01, and this one gives me negative 0.001. Now, why do they all come out to be the same? Well, because you're plugging in the same thing as your x. Okay, so now we have this one is we're waiting on, so here, here, and here, when we're talking about the right-hand side where they're greater than 0, then all of them are going to be 1, right? Because of the piecewise function. So this is 1, 1, 1. So coming to the right side, where we're looking at the limit as x goes to 0 from the negative side, okay, we have f of x equaling 0, because see how these numbers are getting smaller and smaller and smaller, so it's approaching 0. If we have the limit on the other side, x going to 0 from the positive side, then our function is doing what? It's just going to be 1s all the time, so equals 1. So now when we have two things that are the opposite ones coming together in one place, that means that we know that the limit does not exist. So we have, therefore, the limit as x goes to 0 of f of x does not exist, because these two limits are not equal to each other. 0 does not equal 1. So we're okay with that one? Okay, we're going to try another piecewise function. Number 4. Now, on number 4, we have a piecewise function again. This is our y, so our three equations are going to be y equals the absolute value of x minus 2, y equals 3, and y equals x to the third minus 2. Now, I want you to get used to, we've been talking about this in class, is that I want you to get used to being able to tell me what the picture is going to look like. So this one right here has absolute value signs on it. So what do we know it's going to look like? We know it's going to be some sort of v, right? But what does, if my parent function is like g of x equals the absolute value of x, that's going to be a v, right? Right there at this origin. But on this one, we have a transformation. So what is the transformation going to be on this problem? Minus 2. We said inside the function is the opposite of what you would expect, horizontal movement. So horizontally, we're talking about making a change here. So minus 2 you would think would go to the left, but instead it goes to the right. So this is an example of an absolute value that would go to the right. So instead of starting here at the origin, it's going to go 2 to the right and then do its v. Okay, so think in terms of transformations. This one we know is a horizontal line, right? Because everything that's y equals is going to be a horizontal line because you cut the y-axis. And this one, I sometimes call it the snake shape. So this one is the one that starts low and goes high. But now we've got a minus 2. So a minus 2 on the outside of the function is the one that moves us up and down. So we're going to do the, it doesn't matter which one we do first, I guess. So this is going to be our origin, right? So if I'm doing the absolute value in minus 2, we said moved it to the right 2, so I'm coming to the right 2. Now you got to remind yourself that you got restrictions on these things. So this one is to the right 2, absolute value, but it also says that x has to be greater than 1. So we can only go from 1 on up. So here we're going to have a open circle, and why did I pick an open circle? Because this one has an open circle because it only has a greater than or equal to, doesn't have an equal to, it has a greater than only. And so this one we're going to go dot, dot, dot. So it goes on forever. The middle one, y equals 3. In this case, since we don't have any other values for it, y equals 3 is just a point. So 1, 2, 3. The next one is going to be the cube minus 2. So we go down 2, 1, 2, and put a dot. And then we go up, and that's where we have to start. So we have an open circle here, and then we continue on with it down here. So the first thing we're going to do is we're going to find the things in the chart. So we're going to go 0.9, you look at that in the calculator, negative 1.271, 0.99, negative 1.0297, and next one, negative 1.003, and then we have 0.999, 0.99, and 0.9. So what is it approaching? Well, if we come from this side, it's approaching negative 1, right? And if we approach it from this side, it's approaching what? Positive 1. So if the limit as x goes to 1 from the negative side of f of x equals negative 1, see how these are all negative ones? And this one, the limit as x goes to 1 from the positive side of f of x is equal to positive 1, then they're not going to be the same, right? So we're going to have, this would be not equal to each other. So we would have f of x, the limit as x goes to 1 of f of x does not exist. And that's one of those therefore things, right? Because these two things are not equal. Here's a 1 and here's a negative 1. Since 1 doesn't equal negative 1, then we know that these two things are not going to be, does not exist. All right, so we're going to kind of bring it all together. So the limit of a function f of x as x approaches the number c exists if and only if what? Both sides, so both sided limits exist at x equals c. And on this right here, you can also see it again too, because if I'm coming down this way towards it, it's going to be positive 1, and when I'm coming this way, it's going to be negative 1. So you can see where they're different. Both one-sided limits are equal at x equals c. Okay, that one before was, this one wasn't, right? And then, as we said before, the limit as x goes to c of f of x equals L. If and only if the limit from the left side, x approaches c from the negative side of f of x, equals the limit as x goes to c from the positive side of f of x. Okay, that's where they come together as the same number, equals L. Okay? All right, next thing we're going to look at then is in our textbook. So it should be on the assignment though. Page 904, 5 through 8, 17 through 20, and 29 and 30. So basically what you guys have to do is on these you have to write the charts. So I'm going to give you the first chart, and then you guys are going to fill in the next two charts from the next time. And then we'll see what we can do with putting them all together. So you're supposed to be on page 904. So page 904. The first one is a chart. Get you on number 5 here. Okay, so I want you to go ahead and copy down number 5, and then we're going to talk about it really quickly. Okay, so the things that I wanted you to make sure you copied down were these things from the chart, so that we can talk about those a little bit later. Okay? Now, as x approaches 4, you can see from the chart that f of x approaches 1/4. So again, we'll talk about that in a future video. The next one we're going to look at from that homework assignment, the ones that we don't do in the video are the ones that I want you guys to try on your own, and then I'll give you the key later, is number 29, where we have to graph our own function. Okay, so we're going to number 29 is on the next page. Got too many papers here. Okay, number 29 is f of x equals x squared and 6 minus x if x is less than or equal to 2 and if x is greater than 2. Okay, so let's go ahead and get this paper out of the way because we really don't need it. All right, so this is our piecewise function, and this is number 29 from that assignment. And like I said, what I'll do is afterwards I'll give you a key, but I'm going to ask you guys to at least try some of these before we give you the key. So this is like saying my y, f of x and y. So I've got y equals x squared, and I've got y equals 6 minus x. So I want you to get used to being able to look at an equation and be able to tell me what it's a picture of. So y equals x squared is going to be a picture of a what? A parabola, right, because we have x squared. So if I give you a picture of this parabola, the parabola is going to look something like this. We're going to plot dots when we do the real one. Why does it open up? Well, this is a positive 1, so we know if a parabola has a positive a, then it's going to open up. We'll talk more about that with some more of the parabolas. But for right now, we're going to have this one. We're going to reorder it. Y equals negative x plus 6. So this is the same thing as saying y equals negative 1 over 1x plus 6. So what form of a line is this? Oh, I gave it away. What is this? First, it's a line, because they're to the first power, right? Linear. And this would be my y equals mx plus b. B is my y-intercept, and m is my slope. So that we have now our slope, and we have a y-intercept to be able to graph it. So we're going to graph our graph. So the first one we're looking at is this one. Now, it says less than or equal to 2. So at 2, it's going to end up stopping, okay? So we've got y equals x squared. So we're going to graph 0, 0. So if I put 0 in, it's going to be 0. If I put 1 in, 1 squared is 1, so 1 and 1. If I put negative 1 in, negative 1 is positive 1, good. If I put in 2, then I've got 1, 2, 3, 4. Now, at this number 4 right here is where x is equal to 2. So we have to decide, is it going to be a filled-in dot, or is it going to be an open circle? So we go back to our original problem, and we see that x is less than or equal to 2 is going to be a filled-in dot. So we have a filled-in dot at this point right here. So now we go over here and we do 2 to the left and up 4. And so we have our parabola. But now this one's going to come down and go around like that. But on this side it's stopping, and on this side it's just continuing on. Okay, and that'll be something we'll take into consideration later. So now I've got my line for the other part. The line is where x is greater than 2. So greater than means I'm going to have an open circle. In this case right here, though, they connect up. So we'll see what happens. So we have the line is going to go up 6, because that's our b, right? So I'm going up 1, 2, 3, 4, 5, 6. And we try to make our marks as accurate as possible, and sometimes that's hard. So I have 1, 2, 3, 4, 5, 6, and I'm just going to kind of gently draw this because we're not taking all of it. So I'm going to go down 1, over 1, down 1, over 1. So see how it connects up with that right there? So down 1, over 1. We're not taking this part because that would be less than 2, but now we got to go greater than 2. So our line is going to do something like this. So we use the parabola, and we use this line coming down this way. Okay? All right, so now we're going to read some values off of our picture. So this is 2, and this is 1 and 1, and this is 6, and this is 4. So it kind of gives us some bearings. So the first one says a, the limit as x goes to 2 from the negative side of f of x. Okay, so we're approaching from the left side, going this way, this way, this way. Now we see 2. So what do we say? Ask yourself, what is the y? So ask, what is the y? And so at 2, what's my y? 4. So my answer is going to be 4. Okay, so B part, the limit as x goes to 2 from the positive side of f of x. What do you get for it? So we're going up and up and up until we get to 2, and it's again at positive 4. What's the y value? So the c is the limit of both those two things. So the limit as x goes to 2 then of f of x is going to equal 4. And why? Because both this one and this one equals 4. All right, so now let's look at number 30. So 30, and again, this is still from the assignment from, let me find the page number again in case you didn't write it down. Page 904. So this is from the homework still from page 904, number 30. So we're looking at number 30, and this says f of x equals 2 if x is less than 0, and x plus 1 if x is greater than or equal to 0. Okay, so we're looking at, again, this is my y equals 2, and y equals x plus 1, but we said before, this is the same thing, saying y equals 1 over 1 x plus 1, y equals mx plus b. Here we have y equals 2, so what is y equals 2 graph? And it says it has to be less than 0 when it's y equals 2. So we're going to draw ourselves a graph. So we got 1, 2, so here would be y equals 2, which is a horizontal line, but it's got to start at 0. Now it doesn't have an equal to, so that means it's going to be an open circle. So I'm going to have an open circle on 2, and I'm going to have an arrow to the left, because it says it's less than 0. Okay, then going to the right, we're going to find ourselves a line first, so we go up 1. And this one says greater than or equal to, right? So greater than or equal to means it's going to be a filled-in dotted up 1. And from up 1, we do up 1 and over 1. So up 1 and over 1, so and up 1 and over 1. So we get a line that does something like this. All right, so now we're going to ask ourselves some questions about it. So A says the limit as x goes to 0 from the negative side of f of x. So here's my 0, right? So what happens at the limit as x goes to 0 from the negative side? So here's from this side, go, 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 go. Oops, there I am. What am I at? 2, right? So equals 2. The B one says the limit as x goes to 0 from the positive side. That would be here. And there we are. We're down at positive 1. So f of x equals positive 1. But now we see that they're different. So this one is 2, and this one is 1. So what do we say about C? The limit as x goes to 0 of f of x is going to be d and e, which means does not exist. So the rest of the ones that are on that assignment are ones that I want you to try on your own, and then we'll come together and we'll finish it out after we've had a few more assignments. So thank you very much. Let me know if you have any questions. Bye.